what I wanted to share is like a different perspective to think about binary search. So let's think about that, a different perspective. So I'll take some larger inputs. So let's try with the larger inputs. So we'll take some of the elements who is like, I'll again write the inputs. -1, then it's 0, then it's 1, then 2, 3, 5, 7, 9, 10, 12. So we have already defined, suppose we have our target. We have our target as 7. So we already define a condition like all these elements are less than the 7, and this is equals to 7, and all these elements are greater than the 7. So can we say all these elements are less than the 7? Then we can say it as a false condition. And all these elements greater than the 7, we also can say it as false condition. And since this mid is equals to the 7, this element is equals to the 7, then we can say it as true condition. But if you see this array, the new condition array, then it will not be sorted. Like we have defined something false, then true, then we have defined something false. So what I'm gonna do is like, suppose we define a condition where we make everything less than the target as false and everything else as true. What does that mean? So this means like we define a function here. We define a function here. I'll write it at in different color, where x is greater than equals to target. Yeah, this will be our function. So what does this specifies? This specifies like we are defining false for every element that is less than the target. So we are defining false for every element. All these elements are less than the target, so our condition will be false. Our condition returns false. And for every element that is greater than or equals to target, we will be having true. So let's change the color. So we'll be having true. Here we'll be having true, 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 true. Yeah. So if you will see this array, this new condition array, after applying a condition, we got this array. If you will see clearly this array, then it will be very easy to map, and it will be very easy to think of applying the binary search. So how will be applying the binary search is like, you just need to find the first true value. You can see, since you know that all the elements after this true value will be true, then you just need to find this first true value, and this first true value will be our answer. So where the transition happens from false to true, this will be our first true value. And since we define our condition such as, if a condition returns true for some index, say, let's say k, then we know that all the indexes greater than k, like all the indexes greater than k, will also return true. We know that because we have defined a condition which is monotonically sorted. That means we can define our function such as, if we found any element returning false condition, then at least what we can guarantee? We can guarantee that all the elements to the left of it, including this, is false. We can guarantee that because we have defined our function such as, like, we have all the false value first, after that we'll have the true values, and we want to find the first true value where the transition occurs from false to true. We want to find this value. So we know that if some of the element returns false, then we know that all the elements, all this including this, will be false. Then what we need to do is like, we need to search from here to here only. We need to search from here to here for first true value. We need to search for the first true value. Okay, this is first case. And second case is like this. Suppose your search is at this element. Suppose your search is at this element, and this returns true. This index returns true. Then what is the thing that you can guarantee in this type of array? In this type of array, we can guarantee one thing, that if a element returns true for a certain condition, then all the elements to the right of that will also return true. So all the elements to right of it will also return true. That means we can ignore this half and we can search from here to here. Yeah, we can search from here to here, and will not exclude this true value. Why? Because we don't know whether this true value is the first true value or not, so we want to keep it. We will not exclude it. As in the simple binary search, we are excluding the mid value because we already checked for the mid. If target equals to mid, then we will return the index. But here we will not exclude this, because if the mid value is returning true, then we don't know that it's the first true value or not. We want to find the first true value, so we'll include it. But we definitely know that all the elements after this mid will also return true value, because we have defined our condition such that. So we have defined our condition which tells like after false, after a series of false, we'll be having series of true values, and we want to find the first true value. So let's decide how we can find this first true value. So yeah, we have defined this condition, and let's try run how we can find this first true value. So how, let's scroll it a bit. Okay, yeah, yeah, let's define our low to be here. Yeah, this will be the low. Okay, so I'll write this. No, I'll write this. I'll erase it first, and I'll write it something here. So let's erase it. Erase it. Yeah. Erase it. Yeah. Yeah. So we have something like this. So our condition was like, we have defined a condition, our function. So this is something like our f of x is defined as x greater than equals to target. Yeah, so if x is greater than, if the element is greater than equals to target, then it's true. If it's less than, then it's false. So how we are going to solve it, how we are going to find the first true value? And you see, it will be very easy to understand, and it will be very easy to implement to the other complex problems. But the most important thing is to understand how we are going to find this first true value. So let's start the simple binary search. So let's start with our regular low and high values. Then we'll calculate the mid. So mid would something, so this 2 to 4 plus 1 5, we have 2 to 4, so mid will come out to be here. Yeah, this will be our mid. So what we got to know from this mid? We got to know from this mid is like, this mid returns false. The condition on this mid returns false. Then one thing is guaranteed, that including this mid, since it is false, including this mid, every element to the left of mid will also return false, because we have defined our function such that. So this whole thing including this mid will return false. Then what we need to is like, we need to neglect this part. We don't want to search on this part, because we want to find the first true value. So we don't want to search in this part. So how will you reduce your search space so that you don't include these elements? It's simple. We'll increase our low to mid plus 1. It's very simple. Low will be here. It's very simple. Okay, then again suppose again calculate the mid value. So mid comes out to be here. Yeah, mid comes out to be here. And now what we got to know from this mid is like, the condition on this mid returns true. That means what we can guarantee? What we can guarantee is like, every element to the right of mid, will also return true. But we don't know if this mid is the first true or not. We don't know yet if this mid is the first true or not. And we know that it's not. This is the first true value. By looking at the example, I can say that, we can see that this is not the first true value. This is the first true value. So what we can do? We can neglect this part, because we know that all the elements to the right of mid will also return true, and since we have a true here, then these cannot be the first true. Since we have already a true here, then these cannot be the first true. So we can neglect this part. we can neglect this part, but we have to keep our mid. We have to keep our mid. What we have to do? We just have to do high equals to mid. Here we did low equals to mid plus 1. Yeah, here we have to do high equals to mid. This will be our new high. Yeah, and now calculate again. So this is the low value, this is the high value, this will be the mid value, this will be the mid value, and now mid is again returns true. Now mid again returns true. Then we know that we have to neglect the right part, because we got it true here, and everything on the right of this will also return true, and that true will not be the first true because we already have a true here. So we want to neglect it, so we'll again apply high equals to mid. So now high will be also here. I'll do a different color. So now here we'll have mid also, we'll have high also, and here we'll have our low value. So we'll calculate the new mid. So new mid will be here, new mid will be this. So this will be new mid. Yeah, this will be the new mid. And since this mid returns false, this returns false, what we are going to do? We are going to do low equals to mid plus 1. So low equals to mid plus 1. So now what happens is like, yeah, we are good. After the last iteration, what we'll have? This will be our low, this will be our high. We have calculated, this is our new mid, and mid returns false. So mid returns false, then what we are doing? We are doing low equals to mid plus 1. So this will be our new low. So since we do low equals to mid plus 1 when condition on mid, condition on f of mid is false. So we do this, and if f of mid is true, then we do high equals to mid, because we want to include mid also. But we know that everything on the right of mid will also return true, and we want to exclude it because we want to find the first true value. So these are the two conditions. So on this case, low will be here and high will be here, and when low and high will come to same point, then I can guarantee with this technique they will always point to the first true value if it exists in array. So we don't want to search for this again, we don't want to search for this again. So if low and high becomes equal, if low and high becomes equal, we want to get out of the while loop, we want to break of the while loop, we want to get out of the while loop. If low becomes equals to high, we want to break out of the high loop, and low and high will be pointing to the same element, that is the first value that returns true. So I'll write it just. So we want to break, when we want to break, when low equals to high, we want to break, then what will be our condition? Our condition will be low is less than high, because when low becomes equals to high, we want to break out of the while loop, we don't want to run the while loop again, and we are not checking or returning anything on the mid. Yeah, we are not returning anything on the mid. So what we defined, okay, yeah, what we define our condition is like, if the condition is true, if the condition is true, then what we want to do? We want to do high equals to mid, because we know that all the elements from mid plus 1 to high will return true. Yeah, will return true. And we want to include mid. Why? Just think, we want to include mid because we don't know that this mid is the first true or not, and we want to find the first true value. That is why we want to include this mid. Otherwise else we'll do low equals to mid plus 1. That means everything from low to mid, including mid, will return false. So we don't want to search for the false value, we just want to search for the first true value if it exists in array. And since, so what is our condition? Our condition is like, if element is greater than equals to target, after the end after the end will be having low equals to high. So we have reached to last element, and this could be the first true element. What I told you, see, there is a condition: if target exists, then return its index, otherwise return -1. That means if target exists, then there will be having our first true value. That means low will point to our first true value, and that would be our answer. And if doesn't exist, then we have to return -1. It's very simple. If target exists, then we guarantee that this technique and with this point of view, with this perspective, we guarantee that low will be the first value, the minimum value satisfying this condition, and the minimum value satisfying this condition is target itself. And if target is present in the array, then this low will be the index of that element. Otherwise this low will point to the last false. So we don't want to return anything, we want to return -1 on that condition. So let's just check, let's just run and check if we have written everything correct. It should be accepted, and let's try to submit it. And yeah, it got accepted and we applied. And we are going to do a lot of questions using this technique, and I'll show you how we'll use this technique to solve medium and hard problems on LeetCode. So if you love the concept and if you like the concept, then please do like, subscribe, and add a comment for your valuable feedbacks. I'll be reading all those comments,